Okay, so from here, if we were to just apply this formula, I for vertical rod is equal to 1/12 multiplied by 0.28, length is 3, plus by 0.28. Bear with me, okay? Some of you might say, why didn't I use the other formula directly? Bear with me. Okay. So this will be equal to 0.28 times by 3 squared by 12 plus 1.28 times 3 divided by 4 is equal to 0.84 slug feet squared. Okay. Now we derive this formula out, right? ml cubed ml squared over 3. Okay. If we go to the formula, you see the same thing. Can you see this? 1/3 ml squared. Sorry, I know the print is pretty bad. Can you see that? Yes or no? Right? It's 1/3 what? ml squared. And when it's 1/3 ml squared, means they take the point of origin from where? That point. Can you see that? Okay. And so the x and y, this is from the what? From G, which is the center of gravity. Are we clear? Okay. So you decide, okay, however you want to eat your hamburger. Okay. So now if we were to use method number 2, where you use Ix prime is equal to 1/3 ml squared. So 1/3, hey, why do I put square? 1/3, and then the mass is 0.28, and the length is 3 squared. This will equal to 0.28 times by 3 squared divided by 3 is equal to 0.84. We clear? Same answer. Whatever you're comfortable. Okay. The thing is, you have to know when to shift and when not to. You realize when we use this formula, right? Oh, sorry, I should not call it IVR. You realize when I use IVR, right? We just did 1/3 ml squared. We did not consider what? We did not consider what? MD squared. Why? Because when we derive, the MD squared is already considered. Yes or no? When we derive over here, we already consider the what? This over here is your what? MD squared. Okay. So a lot of times I've been teaching this course. Maybe this is my 4th time. Okay. Students don't get mixed up. Don't get mixed up. Are we clear? Okay. Right. So the next thing that we are going to look at is we are going to focus on the what? We are going to focus on the horizontal rod. Okay, and I'll bring the diagram down so you'll not be so confused. So on the horizontal rod, right, we know this is the G for horizontal rod. Okay, and this is the diagram. Okay, and we know the formula to use for the I horizontal rod will be equal to what? Again, we have to take, so now the rod can rotate either this direction or this direction. Okay. So we know that we are going to use 1/12 ml squared plus by what? D squared. Okay. So now we know that the length is the same, so the mass is the same. So 1 over 12 times by the mass of what? What was it before? 0.28. The length is equal to 3 squared. Plus by the mass again. Now, what is D equal to now? Okay, D is equal to what? The distance from here to here. Now, this is our what? D. Okay. So for this case, we have half times 1.28 times 3 times 3 plus 1.28 times 2 times 2. You get, wait, not half, Eugene, 1 over 12. 1 over 12 times 0.28 times 3 times 3 plus 1.28 times 2 times 2 is equal to 1.33. Okay, slug feet squared. Question for you. Can I use 1/3 ml squared? Yeah, you can't. Are we clear? Hey, don't like, oh, we're good to go. We're good to use 1/3. We can't. Are we clear? Why we can't? Because the point of interest is an offset, yes or no? The other one you could, right? The other one you could, because it's on top of here that correspond to this x prime and y prime. Are we clear? Okay, so be very what? Be very careful. Okay. And then finally, the I for the entire structure is 0.84 plus by 1.33. Okay, so 0.84. Okay. My calculator says syntax error. 1.33 plus by 0.84. 2.17. We clear? Okay. Now, we're going to do another one. Okay, this is fun, yes or no? Right, this is the fun part. I'm glad that you find it amusing. We're going to do another one. Okay, where is the... We're going to do this one. We're going to do a combination of two. Okay, we are going to do this question. Okay, so I will do two questions side by side, and I want you to see the difference. Pardon me, okay? So you also have this. Okay, I'll put this over this side. Okay. I want to do the question side by side because I want you to see the difference, the most important thing. Okay. Right. So first of all, we're going to do 17.20 first. Then on the same page, we're going to do 17.19. Okay. The pendulum consists of two slender rods. Okay, so again, it tells us what it is. AB and OC, which has a mass of 3 kilograms per meter. Okay. The thin plate, again, look at what component is telling us. The thin plate has a mass of 12 kilogram meter squared. Determine the moment inertia of the pendulum about an axis perpendicular to the page and passing through this pin at where? At O. Oh. Okay. And then the next one, if we were to look at the next question, same figure that we are going to refer to. I repeat again, same figure that we're going to refer to. Right? The next question. Again, very similar information. The pendulum consists of a 2 slender rod, okay, and a mass of 3 kilograms. The thin plate, this is still the same. Determine the location of y prime or y bar of the center of mass G of the pendulum. Okay, so we have to determine what y bar. Did Dr. Koshi taught you all bending moment yet? So if I were to tell you stress, normal stress is equal to my over I, you have not a clue what is going on. Okay, it's okay, it's okay. He's so slow. Then calculate the moment. But you guys have done bending moment diagram and shear force diagram, yes or no? But no more. Okay, it's okay. I have to tell him hurry up. Pali pali. Then calculate the moment of inertia of the perpendiculum about the axis to the page and passing through what? Passing through G. Two very different, right? The one on the left-hand side is passing through O. The one on the right-hand side is passing through what? G. So that's why I want to do both problems together so you all can see the what? The difference. Now, sometimes it's more convenient to analyze when it's passing through O. Sometimes it's more convenient knowing or knowing it when it's passing through G. Okay, later on, I will tell you when to use what. Okay, so first now, just learn the basic stuff. Just the basic stuff first. Right, so we already know what the two structures are. So one is a slender rod, so I'm going to copy this image. Okay, so you're going to use this. We go over here. We're going to paste this diagram here. Okay. And then the next diagram we're going to use, it did highlight to us that these are thin plates. Yes or no? Okay. So you go over to here, right? So you ask yourself, is it a cylinder? No, they say it's a thin plate. So thin circular disc, good enough. Are we clear? So we're going to take this. Okay. So we are going to refer to this. Okay. Formula that we're going to use will be I is equal to Ig plus by md squared. Okay, these are the formula that we're going to use. So everything we need mass. Okay, everything we do over here, we need mass. So we are going to call this HR, horizontal rod, vertical rod, solid disc, hollow disc. Okay. This is important how you label them. Yeah, you don't call your kid like apple or orange, right? Sorry, some do, but anyway. Dark humor coming in again. So we are going to look at the mass now. Okay. So from here, we are going to calculate the mass of the horizontal rod. So this is equal to what? So the thing is 0.8 times 3. 0.8 is equal to 2.4 kilogram. Then the mass of the vertical rod, again, 1.5 multiplied by 3. So this is equal to 4.5 kilogram. Then we have the mass of the solid disk. So the solid disk, we have to find the cross-sectional area because we are given what? 12 kilogram per meter squared. So pi